In this video, we're going to look at the superposition of two transverse waves. The simulation shows a red wave traveling to the left plus a blue wave traveling to the right, and the sum of those two waves is the purple wave at the bottom. If we pause, you can verify that this actually works. So if you take, let's say we take this position right here, where the red wave is almost 1, the blue wave is 1, and the purple wave is almost 2. So it's just directly the sum of the red plus the blue equals the purple. Over on the right, we have the wavelengths and amplitudes of the waves that we can adjust if we want to see what happens. So you'll notice that when the wavelengths of the red and blue waves are different, the pattern of the purple wave is just sort of a funny looking pattern that's traveling across the page. Now, what we want to do is we want to try to make the purple pattern remain as a stationary pattern called a standing wave. And the way we do that is to adjust the wavelengths so that they are equal. So if I move the blue one to be the same as the red one, you'll notice that now it doesn't look like the purple wave is traveling across the screen. It looks like that purple wave is simply oscillating back and forth. Now, although this is a standing wave, it is not what's called a normal mode of oscillation for a string that would be fixed at both ends. And the way that we know that is you look at the right end and the left end of this screen, and if this were a string and it was attached, the right and left ends can't move above and below the zero. So this is not a normal mode if the string were 10 meters long. One gradation is 1 meter. So in order to get a pattern that has the ends fixed, we have to go down to 2. Now there are multiple wavelengths that this works for. We'll just show a couple of them. Okay. If the wavelength of the red and the blue are both 2 meters, notice now the purple wave, the right and left ends are fixed. This is a normal mode of oscillation for this purple wave. Now, to quantify that, we would say we count the half loops of the purple wave. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would say that this is the 10th harmonic that this purple wave is oscillating in. So the formula, we'll look at the formula in a minute, but the formula is that it's twice the length of the string divided by the wavelength, and that gives the n for the harmonic. So the string is 10 meters long, 2 times 10 is 20, divided by 2 is 10. That's why n equals 10. And that formula always has to work. So if we want the next normal mode, we go up to 2.5 will work. Move these to 2.5. Oops. Okay, the 2 wavelengths are now 2.5. And you'll notice there's another normal mode. Now we know it's a normal mode because the ends are fixed, and the nodes are the points where the purple wave passes through 0. So there's one at either end, then here's one, and there's one, and there's one, and so on. So let's pause and count half loops. 1, 2, 3, 4, 5, 6, 7, 8. This is n equals 8. Because 2 times L, 20 meters, divided by the wavelength, 2.5 equals 8. Okay, we'll just show one more. 5 is also a normal mode. So when the 2 wavelengths are 5, we'll get a nice standing wave pattern. And there it is. So that purple string is oscillating in the n equals 4 normal mode. Now, it's also called a harmonic, so it's the 4th harmonic. Sometimes it's also called an overtone, but unfortunately it's called the 3rd overtone, even though it's the 4th harmonic. Now, the formula to figure these out is on a page of your PowerPoints for this chapter, and you'll see here's the formula, that the wavelength, the nth wavelength of a normal mode is 2L over n. The frequencies corresponding to that are nv over 2L, because remember, frequency is just speed divided by wavelength. When n is 1, it's called the fundamental. So this picture on the top right, that's called the fundamental frequency of oscillation. And then we have the second harmonic, third harmonic, and fourth harmonic. The A stands for antinode, the N stands for node. If the string is fixed at both ends, you always have to have a node at both ends. Okay, that's it.